All right, so now my name is Aaron Edwards, and I'm Director of Technical Marketing here at Cloudgenix. And we're going to go through now talk about our application analytics and path selection algorithms. So what did we want to do to be able to build this application-based path selection algorithm? One of the things we wanted to do is we wanted to, as we were saying earlier, we have to understand how things are performing on the network at an application level to be able, in our opinion, to make a good path selection based on an application. We also need to be able to see if things are browning out at an application level. We also need to maintain symmetry, because we may have firewalls or other stateful devices in the network, and be able to interoperate with existing branches. We don't want people to have to go out and make major changes to their branches to be able to integrate this system into their network. And finally, but most importantly, no need to put a local terminating proxy, no need to decrypt the applications to be able to do all of this type of path decision. This was all of our design goals as we were going into making this solution for the network. And from analytics standpoint, a lot of the same types of items. We didn't want to have to be able to get this information to make the decisions. We didn't want to have to decrypt the application. We didn't want to require agents on the server side or the branch. We wanted things to give us information that we could immediately act on, and also be able to identify codecs, information, sub-applications, and whether things were enterprise or non-enterprise applications. And what ended up coming out is that we ended up taking a chain of different types of stuff. Layer 3 reachability, obviously. Everyone and their mom says, is there latency jitter loss on the network? But then we also wanted to have information about layer 7 reachability. So am I able to reach that app? Are these connections able, at layer 4 level, able to complete? Our layer 7, are we able to get transactions going through, or is the server spinning and waiting for stuff to come back? And that comes into performance. Also, when I am making transactions, are they adhering to the average? Are they doing well as what I would expect from this site, or is it completely outside of baseline? So per application controls is critical at the voice, video, and application transaction time level to be able to make applications, to make your network work. So if I have an application that is performing poorly on link A, I want to be able to move it to link B. Video, voice MOS scores, video kind of a experimental MOS type score that we're working on for the video side of it, and application transaction time. So that data that we talked a little bit earlier about how well an application is sending data back and forth on the network. This lets us do things like be able to pick MPLS is performing better than my VPN. Go ahead, Karishma. Also, when I'm doing video and audio over different paths, let's say I don't have QoS on the internet. That's one of the big problems is that you can't really do true QoS end-to-end on the internet, but the internet may actually perform better than my MPLS that's congested and has great QoS. How do we know? Well, using MOS score and using other information, we can see how well an application is performing and then move it as it needs. And then finally, the favorite one is that we also need to be able to perform and be able to see these metrics in a place that we don't exist. So for example, Link is always the one that customers like to use. I've got Link going to the cloud. I'm using cloud-based Link with Office 365. Which ISP, I've got internet links, I've got MPLS, which is working. And ISP2, for example, doesn't have enough bandwidth for the codec. One of the things that we look at also doesn't perform well going back and forth, so we will take it out of rotation when we're putting new sessions and new flows into the mix.
So right now, of your tests, POCs, customers, how many are looking at you guys for, let's say, zero-touch provisioning versus more control over application steering and things like that?
So everyone is looking at us for application level control. The zero-touch provisioning is just, I don't want to say it's a nice to have, it's just a table stakes capability.
Right.
I don't think you should be in this market if you require a high-touch connection.
So what we're seeing is you can actually see the actual information for the audio calls. And in this audio call, you can see the average of all the MOS scores that we're going through the network. And so, as you can see here, it's very good, going from the client to server. And then
Anyone want to take a guess why we show the client to server and the server to client MOS scores from the branch?
Might go different directions.
Hmm?
Might go different directions.
No. Wireless.
Yes.
We had a couple of scenarios where people were complaining about poor voice quality.
Yep.
And when we measured the MOS score from the WAN into the LAN, it was good. right? But then when we looked at it from the LAN into the WAN, it was bad.
Yep.
And the answer in both cases ended up being AirPlay, introducing something on the order of 10-15% packet loss on the wireless network, right?
Yep.
So without having the ability to see in the LAN to WAN side, you would be sitting there trying to figure out what was going on.
Yeah, very important. Yeah, so this is, as we were talking about earlier, being able to break out the actual application information by the different components is really important. So what we have here is we have 3 different components that you see in the network here. So we have application transaction quality metric, network transaction time normalized, which is our own metric that we use with network transaction times, round trip time, so the actual round trip time on the application, and then finally the server response time. So here you can see in this value, the server response time is the purple line, and the network response time is the actual green line. So you can see here, answering your question earlier, you can tell based on the green and purple lines which one is the actual cause of the problem. So here you can see that the network transaction time is, the server response time and the round trip time. So on the round trip time, you can see that the round trip time is higher than the actual server response time. So the actual network latency in this scenario is actually taking longer than the actual server to respond.
And this is very useful when you're trying to look for changes in performance and changes in behavior, because what you want to see is if John or Jill calls in and says the application is no longer working as well as it used to, one, you'll be able to say, well, yes it is, or no it isn't.
Yeah.
And 2, you'll be able to say, oh, the server response time has spiked, or the network component has spiked.
So server response time is measured from the time it gets delivered to the far end of the connection to the time you get the response back.
Right, from the time it was actually delivered to the server, or we estimate that it was delivered to the server, till the time the server actually comes back with information.
So something in line in that, so firewall, anything in between could potentially manipulate that metric.
Exactly.
So your round trip time is just
The first TCP termination point in the data center.
right. That makes sense.
So if, let's say, it depends on where the app is actually at. So when you're using an internet app like a SaaS app, once you hand it off to the internet, you really lose control. So to us, all that stuff is server response time. Yeah, it could be.
Actually, it'll still be the TCP termination point
Yes.
at the cloud
Yes,
provider edge.
I
So
was-
we will be able to still decouple the WAN from the server. And this actually happened to me. I had a heart attack almost at one of our public sessions because Office 365 was showing as red all over the place. And as it turns out, they were having a series of micro outages that we were able to show that it was server related.
So you say at the cloud provider edge, you're talking, so let's just say Office 365 is what we're talking about.
Yep.
You've identified what their edge is.
We don't need to.
So you hand it off to the internet.
Remember, we're measuring at the TCP level. So you can look at the TCP heuristics. And if you go to the slide that we showed earlier about the TCP session behavior, where we look at the client to server request acknowledged, so where I say I want to talk to you, and then you say, yep, I acknowledge you and you can talk to me, then there's this period of time for the server to actually process the information. That's what we measure as the server response time.
So is that then just a differential between
Yes.
round trip time?
Yeah.
So you're taking a look at round trip time, and then you're adding on any latency added by
No.
response. But I'm trying to understand how you're getting to
Could
it.
you go back to the chart where we show the actual transaction session?
It may not be that important.
The round trip time is TCP ACK time
Yeah.
through the duration of the session, right? And that's why you care where,
Yeah.
or why you talk about where the first TCP termination point is, because
Yeah.
that's the thing generating ACKs.
That's right. And then the NTT, the network transfer time, is the time that it takes for the result transaction to be sent to you.
Yes.
I want to ask what's probably a stupid question, but looking at it more, we're trying to identify what's introducing latency into an equation, basically. So you have traffic one way, it's hitting the server, so there's a big gap there. Something's happening at the server side or the application side, and then you're talking about things coming back. Are you able to integrate with anything on the server side? So rather than saying, oops, not us, I'm not saying you in general, you specifically, I'm saying just in general, oops, not us, but you're able to say, okay, actually it's because we had this much storage latency in this. Are you able to integrate with statistics at the application and server side so that you get a big picture view of where all latency is taking place, so that you can actually identify root cause rather than just the process of elimination?
Not yet. So that's a good question. In that we want to be able to take the information that we need to determine at this point what the actual network problem is. So the thing that we're trying to route around is if there's a network problem.
Right.
So we're focusing on the network side of it, and we are saying that the server side right now is a black box. That if there's a server problem, we don't identify the specific detailed server side of it.
And I'm not saying you would identify it. What I'm saying is, will you eventually integrate into something else where you could basically get that kind of information?
So all of this transactional data is stored in a Mongo database where we have full RESTful APIs to access. So a customer, a vendor can mine this data and integrate it and use it to correlate to whatever tools that they want. So we'll give you all of the raw information. We'll give you the specifications for the API, but we're not actually going to go in and build a plugin for your server troubleshooting tools.
I want to add. Oh, you can.
No, that's
I want to add about Face, for example. The majority of the application we focus on the cloud-based application. So, for example, there's a problem with the Skype. Is there any way that, or anything you can integrate by getting a feedback from Skype, telling your application, okay, now no matter what path we choose, it's not going to work unless we change it to another Skype server. You mentioned about during your demo, there's a problem with Office 365, right? So there may be some other information you can fit in to tell us about the availability of the application. Now, you mentioned about the database, but those are the local applications. So the cloud-based application may be different. We don't have visibility.
And I understand that. I'm thinking more about internal, not cloud-based
Right,
stuff.
right.
I'm talking about integrating with vSphere or something like that for metrics.
So all of our information is accessible via an API.
Okay.
We don't hide it. It's not in a proprietary format.
Yep.
It belongs to the customer, and the customer could do with it as they please.
Yeah. The data is definitely there.
It's a key concept, and when we say the network latency, well, latency, packet loss, jitter, or latency, packet loss, and bandwidth are all related.
Yep.
Right? And one of the things that we see is under high latency conditions, latency or packet loss has a way bigger impact than under low latency conditions. So we actually do all of that calculus for you.
So, can I ask, you've been giving a lot of focus about performance metrics and monitoring. Do you guys feel like you're confident enough to go into a customer and say, if you're also using a network performance monitoring solution, you might not need that anymore? Or are you saying this is a value add?
So we are not positioning ourselves in the market as an APNM solution.
Yeah.
We do have customers who are basically questioning the spend that they have on their existing tools, but that's not our primary focus.
Yeah. As Vijay said, to expand on that, the information that we give, as I was saying earlier, was about trying to be able to make a network level decision. And so there's a lot of things that APM tools can do, things like terminate the encryption.
Right, when you're talking about, and also right on the application itself, there's a lot of...
Exactly. They might, like agents and things like that. So
we have a potential customer that's spending $1 million on an APNM solution a year. They're reevaluating whether they need to do that anymore.
Right.
That's up to them.
Right.
We're not going to try to do the features to do everything that the APNM solutions do.
Yeah.
It's just
I see customers, again, a lot of them mid-market have no visibility at all today. So this would be a huge value add in general.
Yeah.
Right, and you guys are collecting the information for your own purposes. I mean, I understand it. Like, it's great that all that information is there, but you need that for your delivery of the service that you're promising to deliver. So the fact that it's there isn't for another purpose. It's just there so you guys can do what you need to do, and you're making it visible. Yeah.
Good point.
so
Extra
interesting.
added benefit.
So I mentioned retail, right? Black Friday. The job of a retail store IT person is to maximize the number of successful credit card swipes that they can do in any unit of time. So we can actually show the customer each and every credit card swipe that's happening, how many session errors that are happening by path, and what the typical application transaction time is versus the server delay. Hugely valuable information, not just from a networking decision perspective, but from either a SecOps or even a retail store manager's perspective.
So now what we're going to do is we're going to introduce latency just for a specific. We're going to introduce packet loss for a specific app, and we're going to show us detecting that the app performance has gone down, and just move only that app over to another link.
Yeah, and right now we have a bunch of other applications in our branch. As you can see, I've just pulled up the top 10 apps, and now I will filter only by Google. So let's
Google, okay,
Yeah,
nice.
clear this all.
Which Google app are you going to do? Just the straight
Just the
Google?
straight
Okay.
Google,
So
yeah.
the nondescript Google. Okay.
That's right.
Yep.
Okay. And let us quickly see what's the path Google is flowing on. Filter by WAN.
So while she's doing this, I want to do a plug for Erin. Erin has written a little extension to a WAN emulator tool where you can introduce layer 7 types of packet loss issues or latency on a per application basis to be able to better do SD-WAN types of testing.
Yeah, we're actually going to release that open source. We call it WAN Bridge. It's based off of another WAN Bridge project, so we're going to be releasing that in the future very shortly. So that way people can test their own.
So right now Google is flowing on direct internet, as we can see. So I'm going to go ahead and brown out the direct internet. So I'm going to do that only for Google. Going right here, I'm going to introduce about 4% packet loss for Google on internet.
And what's interesting is you'll see packet loss impacts applications in a very different way from application to application. Right, so having a raw packet loss number by class of service or DSCP color doesn't really buy you very much. Right, we really focus on how that packet loss impacts application performance, application transaction time.
So I just introduced some packet loss for Google on the WAN bridge, and I'm going to go back to the charts.
And this is a very subtle change too in the back end, is it? Just introducing a little bit of packet loss. What's nice is that what you see with different apps, like for example, the reason we chose 4% with Google is that we see with Google, 4% is really the threshold to where it starts to be noticeable. 1, 2, 3% packet loss, it's not really a huge difference in the actual performance of Google. Google's very optimized, they do a really good job. But when you start getting above that in packet loss, then it starts to be actually the point where it can actually impact a user session.
So basically what happens is what we saw is that the SLA threshold was violated. So there's a smoothing filter on the more granular chart, so you don't go crazy seeing lots and lots of this, but the app health is actually more instantaneous. So you see it go red so that the path is unavailable. I wanted to ask any questions that you may have based on what you've seen.
Integration with my existing network to run a routing protocol and.
So the way we integrate into the network on the data center side is we just do BGP peering. So we BGP peer with the core and the WAN edge. So you actually don't need to make any changes to your topology. We're purely off path, so it makes it very, very easy for us to insert. On the branch side, we don't need to run any routing protocols. On the WAN overlay, we don't run any WAN routing protocols. So it's very, very simple to insert. That's why we're able to bring a branch up and running very, very quickly. There's no stack complexity that needs to be managed.
In your routed mode then at the branch, or are you my IP gateway?
We would be the
You present a couple of these lanes.
Yeah.
Gotcha.
Yeah, we have both inline and routed mode, so it can do either or.
We've talked a lot about failover. Are you guys doing anything with load balancing?
Yes. So what we do is so if a path is allowed to use 3 paths by policy, we will distribute applications on all paths that are within SLA.
Flow-based.
On a
Application user-based, because it's very important for persistency and things like if there happens to be a NAT system in the mix, we have to take all that into account, because at an application level, some applications are fine with users coming from different addresses for the same application flow. Other times they aren't. So this is one of the key things that a lot of people have problems with, is that if I'm just spraying flows across different sites that have different exit points that are different NAT gateways, it's funny, like an application like WebEx actually pukes when you try to log in when that happens. So for example, but once you actually get into the actual WebEx application, you're doing your video, voice, data stuff, that can all come from different addresses. So we have to take all that into account to make sure that a user experience is good.
And on your WAN devices, or your edge devices for like a branch, right? We've talked about the different types of circuits you can have. You bring MPLS directly in, you're plugging it into your device. Are you then doing QoS? Are we able to set up QoS policies on the way out so that we can tag particular traffic so our QoS vendor will treat it accordingly?
Marking?
Marking,
Yeah.
no market.
In fact, if you go to our website, you'll see a demo where we showed an x86 server that was terminating MPLS on a T1, running our software in conjunction with a Palo Alto firewall, single server, internet connectivity, MPLS connectivity.
We'll actually demo some of that I don't know, this afternoon. So
In 20 minutes.
20 minutes, yeah.
Do you have a scheme to make my application redundant over two paths?
So that,
Deliver it twice where I need to?
So we will, all paths that are eligible for that application by policy are used by default.
Well, I mean, the same traffic per line, you mean, right? The same traffic hitting both WANs concurrently?
We do not do packet replication.
Like a mirroring type function?
We do not do packet replication across the WAN.
You just switch between them?
What about hardware resiliency, right? So we've talked about edge devices, and we've talked about, obviously at your core, whatever your, data center is going to be, you're going to want some resiliency, but even at WAN edge, can we put multiple devices out? How do they coordinate action?
So core is horizontally scalable because it's very important from a crypto throughput and a just performance standpoint that your data center side needs to be able to scale out however many you need. On the branch side, typically people want smaller footprint. So either you're doing a VM, if you're doing a VM box, you can do VM redundancy, HA, different types of ways you do it with a VM. And then for the physical devices, we can either do in-path redundancy, so we have multiple devices in path. One assumes the identity of the other in a failure. So, because that's very important for things like internet, because if I have like a commodity internet link that I bring in, I don't want to have to put a hub in there to be able to talk to two different devices. So we can actually plug the same internet connection into both devices and have the second device come up with the same MAC address, all that fun stuff that needs to happen.
So it's like active, passive, failover, and that's like something we can do today.
Yep.